Hello, everyone, and welcome back to What's the Word? I'm your host, Owen Smith, and joined today is John Barragan. Thank you, John. Thank you for taking the time to do so.
Hey man, good to be here.
Great. To start things off, would you be able to tell us a little bit about yourself?
Sure. So my name is John Barragan. Grew up in Sacramento, California. Moved away to go to college at Embry-Riddle-Prescott. My major there was aerospace engineering, aero track, and let's see. I at one point convinced myself I was going to take a systems minor, and that didn't happen. So I just stayed aero track the whole time. When I graduated, I moved to San Diego to chase my now wife. But I also had a job coming off of an internship that I had with Collins Aerospace down in Chula Vista, which is a suburb of San Diego. So I went there right after college. Um, then, right after a lot of the COVID madness, there was some craziness with hiring and layoffs and such, and I decided to leave Collins Aerospace and I took a job at General Atomics. And this whole time I've been a test engineer. So I was a test engineer at Collins Aerospace, and then I took a little bit of a different path, became a flight test engineer at General Atomics, working on the MQ-9A drones, and that was really interesting. And then my wife got into medical school in Phoenix, Arizona. So now I'm back in Arizona after my, what was it, 3 or 4 years absence. And let's see, she's in her third year. So we've been here for 3 years, and I've been a test engineer with Honeywell that whole time. So that's a little bit like kind of a high level summary of my background. And I'd say that I'm glad to be back in Arizona, and especially it makes me closer to Embry-Riddle. I try to get up to Prescott whenever I can, and most of the time when I go back up to Prescott, I go back to Embry-Riddle just to visit.
Yeah, I mean, shoot, that's a great journey going from California up here to Arizona, and then back to San Diego, and then back to Phoenix. And
Yeah, it's been a whirlwind.
what was your favorite memory, I suppose, from your time here at Riddle?
All right, at Riddle, let's see. Uh, there were a lot of great memories. I'd say kind of a general sense of my favorite times there was when I'm a nerd through and through. So being in class and being in labs, I actually enjoyed that. I had a lot of fun with that. So my favorite memories were doing the aero track labs. So experimental aero, messing with the wind tunnels. That was a lot of fun. I actually really enjoyed materials lab. So that's kind of like in a general sense. My favorite times there were working on labs with my friends and really learning a lot and actually getting to do hands-on stuff. And I guess that's kind of evident in my eventual career path of being a test engineer, which is kind of an outgrowth of that, I think. And but I guess if you're asked a specific memory, it's actually not related to school at all. It was my first day there, literally the day I got kind of dropped off to start my freshman year, day one. And it's all exciting, and it's the next step. It's the next step in my journey, and the world is my oyster type of deal. But the memory is, well, the whole day was great, but come
Yeah.
nightfall, there was the biggest monsoon I've ever seen in my life. I'm from, like I said, I'm from Northern California. We don't really get a lot of,
Wow.
definitely don't get a lot of thunderstorms, but even just rain, especially in the kind of recent years, it's
Yeah.
nothing but drought. So coming to Arizona where I hear there's monsoon, it's like, okay, great, there's going to be thunderstorms. But then on this first day, it was the craziest thunderstorm I've ever been in.
Yeah.
Shook the buildings. It was crazy. So and that was like the cool.
Wow.
Definitely not not related, I suppose, to Riddle itself, except for the location. The Prescott is an awesome place, and
Yeah.
I'm really glad that Embry-Riddle was located there, not just for the thunderstorms and the monsoons, but all the hiking and nature around.
Oh, totally. What year was that when you first came in?
Right. So I went to Riddle in I started 2016, so that was don't ask me the date, maybe August, mid-August I think is when yeah, August something 2016, and then graduated May of 2020. So those were my 4 years at Riddle.
Oh wow. Wow. Yeah. Graduated during the COVID madness, as you said.
Yep, we were the we were the first class that had to navigate that. We could get into that if you want, but it was eh, yeah, we didn't really get a graduation. We didn't get to walk, but it was kind of a unique time.
Were you able to come back and a couple years later and walk? I think in 2022.
Uh, Physically able to, no, I would have. There was a chance there for me to walk um, while I was in San Diego because they have a chapter there. It's like one of those
Yes,
small flight and
satellite
business schools, I think.
campus type thing.
Right. Yeah, and they do their graduation ceremony, or at least they had used to do it on an aircraft carrier it's a museum aircraft carrier called the Midway, the USS Midway in San Diego Harbor. I know they used to do that, and I think they stopped doing that, but because of COVID. So I didn't end up getting a chance to walk, but that would have been really cool. So
I'm sorry. So kind of diving into what you're doing now at Honeywell, would you be able to talk about like a typical day to day? Like what is day in the life? What does that look like?
sure. So the nature of test engineering is you don't really have a standard kind of day job. Everything changes with a condition of the test article, or if you have findings during tests that require you to change directions. But in a general sense, um, you have what I call kind of preparatory or design phases, and then you have the kind of build installation phase, and then you have the test phase. So my campus at Honeywell is the engines campus. We do turbofans, turboprops, all kinds of different gas turbine engines. Most of what we have smaller platforms, so most of what we do are on business jets, or we're really well known for our APUs. So we have APUs on a lot of the larger platforms, just the smaller engines that go on those, not the main ones. So that's what we specialize in. So my lab, I'm the lab focal for the cold flow turbine facility. So we're pure development. When we have new turbine technology, we want to test it out to make sure that our models are accurate. So they come to my lab with a new turbine design. Uh, Usually that's installed in what's called a rig, or at least what we call a rig, which is, you have a turbine, either single stage or multi stages of rotors and vanes, and it's mounted up on two bearings, and the thing spins, and you pump air in, and then you extract energy out, and you can control and manipulate the conditions that you're at to kind of mock a flight profile, and you get your performance data. That's really what we're chasing, is performance and efficiency data.
Yeah.
You collect hundreds of points of instrumentation data, whether that's temperatures, pressures, torque, all kinds of things that are needed for engine testing. Um, and then you process the data, and you can go back to your simulation model for what you were expecting the performance to be versus what you got. So you asked, what is a day in the life? So, and then I said there's
Yeah.
three phases. In the design phase, my internal customers are telling me, hey, we have this turbine rig coming in. This is usually on the order of years or many months out before the actual hardware arrives. So they'll say, hey, here's this rig. It does X, Y, Z. These are the technologies we want to test. Um, your facility needs to be able to meet these requirements, and we need to be able to perform these test points. Okay, great. So we have agreement on requirements for my facility to meet their test article requirements. Then I go and design the facility around that set of requirements. And if we have, if there's shortcomings where I can't meet the requirement with equipment that we have on hand, then we have to go procure that equipment. And that's where the real design comes in, is when you're pushing the envelope. And again, we're fully development. We don't do production, so everything we do is different.
Yeah.
So there's a lot of pushing the envelope and design that you have to do. So then you get into and this design phase, like I said, takes years, sometimes years to months, let's say. Then you
Yeah.
get to the installation phase where all the hardware that you bought or prepared or designed for this test needs to get installed. And then you have to install the rig once it is right, once it's been instrumented and ready to go. So
Yeah.
you're building up this test facility, you're instrumenting everything around the turbine and the rig itself. And then you get into the test phase. So first you do a bunch of checks where, okay, let's start turning this thing and see what kind of bearing drag we have, for example. And then you start flowing air and start getting preliminary performance data. You make tweaks with any bugs that you find or you repair instrumentation, and then you get to your full-on test. So a day in the life is it changes seasonally with where we are in the test cycle, but most of what I do is hands-on in the lab, either testing and collecting data, processing data is mostly reserved for the customers who are asking for the data, but there's a lot of times where the test engineer, the test organization has to look into data so that we can solve whatever problems arise during the test.
Yeah.
And then you have your design phase where you're kind of at a computer or you're chasing down hardware, having, coordinating with vendors, that sort of thing.
I gotcha. These test campaigns, how long do they typically last, or is it very dependent on the customer's requirements?
It is dependent, but because turbines are, how should I say this? Turbines require steady state data. We, at least the way our facility is constructed, we don't do transient dynamic data. We take steady state data. So the testing itself takes on the order of several months usually.
Yeah.
And if our customers had more funding, then they would take even longer. They would take years, I'm sure, to collect as much data as they would like. So from kind of conceptual design all the way through test completion and data report out, I've seen test programs take 3, 4, 5 years, something like that.
Wow.
The design phase takes most of that time, and then your test phase, like I said, usually between 3 to 6, 7 months. And
Yeah.
then you have several months of report writing and data processing. So all in all, it does take 3 to 5 years for a test program.
Wow. I did not know it would take that long. You touched on report writing, and I'd like to ask more about that. Like what does that look like? What kind of genre, I suppose, of writing we do, like tech writing or academic writing here in school? Is it very different in your workplace?
I wouldn't say it's very different from the technical writing we did at Embry-Riddle. You have at Embry-Riddle, you have these labs where you have to write reports on the lab that you performed, whatever testing you were performing in the lab, I should say. And it's very similar at Honeywell. When I got to Honeywell, this cold flow turbine facility had not run an actual test in several years. So there was no great documentation or template for how to write a report. So I ended up generating those. So I kind of wrote a first pass and then I edited it and I wrote another pass. And so now that first report that I wrote serves as my template for reports out to customers, to higher ups. Um, Definitely technical writing is the main genre that I have encountered in the workplace, and that goes, all three companies that I've worked for, Collins Aerospace, General Atomics, and Honeywell. In the test role, most of what you're writing is reports. So you're reporting out the data you've collected and your findings and your recommendations. So there's a lot of, what goes into that is you have to present data in a visual format, and then you have to explain it in words. And so it's very similar to what you learn in by performing your labs, but then also in technical and communication class that you have. Actually, there were multiple that I took at Embry-Riddle, so very, very similar.
Kind of tie back in and start closing out. What I suppose do you wish you would have known more about, or just known in general from before leaving Embry-Riddle here and transitioning into the workplace, first at Collins or even in your future career progression at General Atomics or now Honeywell?
Let's see. The biggest thing that I would say that, I think the piece of advice I would give to kind of juniors or seniors, people who are about to enter the workplace, is your learning does not stop when you graduate, or at least it should not. Um, the more learning you do, the more you do to expand your borders of knowledge and competency, it will only help you. So if I was to say I graduated Aero, I'm only going to do Aero, um, and I wasn't willing to expand into other avenues like a test role. So test is Aero. Don't get me wrong. I was testing aerospace components or systems, but test is its own beast. I wasn't designing airfoils, for example. I was performing tests in a lab. So it's a different way of doing things. Um, but you have to be willing to pick up new things and to learn and to keep growing, because if you stop, then you're just closing doors for yourself. So, and I will say this too, everything that you learn at Embry-Riddle is just the foundation. Every job that I've been to, and I've been, like I said, three different jobs, almost everything you learn for those jobs is on the job training. So you have to have the foundational principles that you learn in high school, and then also, of course, at Embry-Riddle in college. Um, that's just your foundation. What really makes you an effective employee, I would argue, is almost completely based off of your work ethic, but also how far you're willing to go, how much you're willing to learn at your job. So never stop learning, never lose your curiosity, never stop taking on responsibility to expand your horizons, and you'll go very far, especially if you could say I jumped around. I would say situations forced me to jump around, but if you were to stay at a company and just keep taking on different positions within the company, you're going to be a jack of all trades, and you'll be um, indispensable. And then also you can keep pursuing your interests, right? So if you keep finding things that you're interested in, and then the more you expand your horizons, the more things you'll find that interest you. So what I'm saying is, don't be content with just where you are. If you keep working hard and you keep trying, keep looking around and expanding your horizons, then it will only help you, and it'll only make you, it'll only satisfy your curiosity. So
Yeah, that's some fantastic advice. Thank you so much. Thank you for joining me today on the podcast.
yeah, thanks. It was great to be here.
This podcast is supported by the Department of Humanities and Communication at Embry-Riddle Aeronautical University in Prescott, Arizona. Our hosts and producers are Owen Smith and Leah Little. I'm Amelia Chesley, Assistant Professor of Professional Writing. Many thanks to the Prescott Campus Writing and Design Lab for hosting our transcripts. The intro and outro music is Wanderer by Alex. You can find us where most podcasts are found. And if you are a Prescott Campus alum, please reach out so we can feature you in a future episode.